Welcome to the VRT Christmas Update 2025, delivered by Matt Lawrence, our Chief Engineer.
Right, can you do that one more time?
No, I'll do it.
Yeah.
No.
Do
Get out of it, I'll do
do
it.
that. What?
You won't let me do it.
Okay.
So, winter 2025, work has started. It's been going now for a couple of months. So Steve and Terry here are taking off the PFCU motors. So there's 8 PFCUs on the back of the aircraft here. PFC motors are coming off to check the gearbox oils to make sure there's no contamination or particles in the oil, to check they're at the correct oil level, and we'll check the rest of the PFCUs out for any leaks, checking out the wiring and everything else in there, making sure it's all in good condition. So we'll work around the back of the aeroplane. So as we come around here, you'll notice number 1 end cap is missing. So that's been taken off to do a structural check of that at the moment and work out what we're going to do. So when 558 was made to fly again, they had to have a number 1 end cap made, and it was an astronomical amount of money. We can't afford that, so we're going to have to look at making one ourselves or repairing the one we've got. So all the access panels are open on the rudder. That's just to check the structure up in there, check everything's in good condition. So really once a year what we're doing is we're taking all the panels down, we maintain a good health check in the aircraft, so if there's any more corrosion growing, check the wiring out, structural defects, that kind of thing there. So on top of the ECM bay there, you've got the parachute bay. So there's some damage that's up there at the moment. We're looking at doing some structural repairs on the parachute bay. The parachute hook mechanism, that's all been taken out. Doing a health check on that, checking for wear and all that good stuff up there. So all the ECM cans have been removed. So the only way you can get the parachute hook out is from the bottom and on the top. So they both come out independently. So the 2 parts of the hook. We've fitted Sky TV. So we've got the tail warning receiver here, or the radar there. So that's been exposed. That's the first time that's been opened up in our time we've had the aeroplane. So as you can see there, all the ECM cans are removed. You can see the rest of the PFCUs at the back here, where they're all hanging down for the oil checks and the gearboxes. So if we go a little bit further forwards, we go into the bomb bay. So in here at the moment, Keith is working on the air brakes. So in those 2 square panels up there, that's where you've got some angled gearboxes. So there's a special type of oil that goes into those gearboxes, and we're having to wait, I think it's around 3 months for that to come to us. So there's quite a long back order of that. Fire bottles, they've been removed for their annual weight check. So that's important. Obviously if we have a fire, you want to be able to put it out. So each year they come out, they're weight checked. So if there's any loss in weight, obviously you know you've got a leak of the agent that's in the bottle. So that's very important that we do a weight check on those. The rest of it, we do a good structural survey of the bomb bay each year, just to check on the longerons, check there's no corrosion that's growing on those. There are little bits here and there that we know about, so that's going to be done in due course. So as we work across, we'll go to the APU. So we've had a problem with the APU. So the APU sits here. So for those that you don't know, normal terms in the industry, we call it an APU. So in RAF, they call it an AAPP. So it's an airborne auxiliary power plant. So the Vulcan, it used to be able to provide compressed air to start the engines and to provide electrics on the ground and in the air below 10,000 feet. So for us, it was the RAF modified it to just supply electrical power. They didn't have to supply air in the end because it was actually cooking the APUs. So it provides electrical power. Our one wasn't providing electrics on the last taxi run that we did. So there was a problem with it. Now, is it the generator? Is it the control unit in the rear power bay? Just didn't know. So we did a load of function checking and tests, and we found out it wasn't the actual generator itself. It was the generator unit or the control unit in the back in the power bay. So John Lamb and Trevor Lockhart, they took the box out, they did a lot of checking on the boxes. So they found that it was a coil unit that was in the control unit that had gone. We found a replacement part. It got fitted. We did a function test. Now it's A-OK, which is good. So undercarriages, all the wheels are off at the moment for cleaning, inspection, tyre changes where needed. There's another set of brake units in the workshop. They're being resealed. These ones, we're going to do a good check of these, wear checks, leak checks, having a good look around those, lubrication, inspections. So one thing with the brake units, we said before in one of the other updates, there's a metal washer that's got a rubber insert on the inside of it. So it's called a bonded washer, made by Doughty. So each brake unit's got 5 pistons and it's got 5 bonded washers. So we're looking at trying to get a set of say 60 to 70 of these bonded washers. The cost is astronomical, so we can't just go and use, you know, from Joe Bloggs down the street. We can't just go and pick a unit up and say that'll be okay. The brakes need to be absolutely as airworthy as we possibly can. So we're having to get these bonded washers made. So 60 of these washers is around £2,500. It's crazy money, but people say, oh yeah, why does it cost so much to do a taxi run? Why does it cost so much for X, Y and Z? You can now see the costs. If we're going down the runway, we want to be absolutely serviceable. So that is our mitigating our risks and our costs. So that's a given. The brakes have to be absolutely airworthy along with the rest of the systems on the aircraft for what we're doing. So the undersides of the wings, you can see all the access panels are removed. So you can see here all the pipe work, the fuel pumps, the secondary pumps, and obviously gaining access to the structure as well. So like I said before, this is the reason why all the access panels are off. So we check the structure, we check the wiring, we check the pipe work. Everything is checked once a year, just for any degradation or any loss of serviceability or anything like that. So every year we inspect it and we make sure everything's safe and as it should be. So let's walk round to the front. So Keith and his merry men have been on the air brakes. They've been doing air brake chain tensions. So basically what you'll do is there's a set procedure in the book. So you'll put a steel rule on the structure and you'll use a spring balance. So you can either push or pull the spring balance. So the ruler will come out and it'll go across the centre of one of the links on the air brake chains. And as you pull the spring balance, you get 3.5 pounds. So what you do is you measure the deflection of the chain. So that is a set value, if you like, and then you get your adjustments. So we check they're correct all the time. Chains do stretch. They do change over the years. But not only that, we check all the air brake system out. Everything's lubricated, inspected. Again, micro switches and their wiring. All of that is checked out to make sure everything is good. Other bits that are going on, engines. There's a health check on the engines, so we either do boroscope, we do soap checks on oil if we can. So this year the starter motors are all being checked out for their oil contents, like they are every year. Fuel filters coming out, going through an ultrasonic bath to check there's no contamination in there. It happens in old aeroplanes, so jet fuel inherently gets water in the fuel, and it plays absolute havoc with jet engines and their fuel systems. If there's any water or contamination in the fuel, it's basically a fungus and it'll grow inside the fuel with the water. So every time we refuel the aeroplane, and another couple of times a year, we go through all of the fuel tanks and there's little water drains. So you open up the water drain, you drain a couple of litres of fuel out and you check if there's any water in the fuel or any contaminant. If there is, you keep draining until the water's gone and until all the little particles stop coming out. That's the best you can do, or you can put a biocide into the fuel as well. So that's something we're looking to do. Other bits we're doing on number 2 engine, we've had a high energy ignition unit failure. So the intake's been taken out. We can show you that if you want. It's a big dark hole. So as you look at the front of the engine, to the front of the engine here, when you look right up to the top of the bay, which is a really stupid design, the high energy ignition units would sit over the top of the front of the engine. So one thing is in industry is serviceability issues. So with a modern airliner, you've got access to the high energy ignition units straight away. With a Vulcan, it's pretty rubbish. So if you get a high energy ignition unit failure, you have to take the whole of the intake out just to get to the boxes. So the aircraft is grounded for, say, what, a morning or a day, whatever. It's a bit of a crap design. It is what it is. But we've got some other serviceable units that we're going to refit. Another thing that is going to happen this year as well is the rigging on the engines, so for the throttles. So one thing that has been noticed, or I've noticed, and that is when you're at a certain power setting, we've got a thing called throttle stagger. So at different sets, the throttles can be in different positions. So at full power, they're absolutely in line, no problem. When they're at idle, they're no problem. But mid-set power, you've got a stagger. So that's something we're going to look at and do some more setting up of those. So as we work further forwards, you can see more panels are off. Again, purely for inspections and checking that structure and the wiring and the fuel systems again. So when we come to the front, there's something missing here. So that's a steering motor. It was swapped last year, but there's a leak on the piston seal, on the ram seal. So that's now come out. That's going to have to be resealed. Another challenge is trying to find some of these O-rings and trying to get them manufactured. Again, it's cost, but serviceability, you can't really put a cost on that, and safety. So we get the right seals, we do the job, we do it right, which is the way forwards. Again, while the wheels are off, everything's checked out. The shock strut will be charged with OX16, which is the most expensive fluid known to man. So OX16, you have to get it made. It's crazy money. So when you look up into the nose bay up here, we're doing quite a lot of work up here. So basically we call it a hydraulic cupboard, if you like. So there's a lot of services in this area up here with the hydraulics. So what you have got is it's the braking controls. So when the pilot or the co-pilot puts their feet on the brake foot pedals, it sends a signal down to a brake control valve, and it's metered pressure. So when the pilot or co-pilot puts his feet on the brake pedals, on the foot motors, the amount of pressure you put on the actual pedal itself comes down to the brake control valve, and then it's proportional force that is sent out to the brake units. So the brake control valve, we've got another couple of units, they're going to go away for testing. Obviously they need to be absolutely 100%. A lot of the pipes up there need removing, they need either pressure testing or they need replacement. So it's now of an age where you need to check all these pipes out and the systems. So one thing we do every year is 150% working pressure test of all the hydraulic systems. So we pump all the systems up to 150% of the working pressure. If something pops, you've done the test, you know where to replace and you know what to do. So now it's the right time to take all this hydraulic cupboard out, to replace all the pipes, check all the valves out, do what we need to do up there, and it'll keep us serviceable for many years to come. So one thing we did find as well up there on the fuse board at the back there was a couple of wires that had turned green, so they're tarnished, and on actual further inspection the wires had actually come apart. So now it's a case of, it's an old aircraft, you need to chase the wiring out, you need to, I think we call it belling out or ringing it out. So that's one end of the wire to the other end of the wire. Where does it go? So the wiring diagrams are great. If it's a Boeing or an Airbus, it will tell you the wiring ident, where to go to look, and it'll tell you what to have for dinner basically. On this, you have to go absolutely back to basics. So you have to understand the wiring diagrams, where the wiring starts, where it finishes. So if you've got a break in a wire somewhere in the middle, where does it go to? So this is where you need to be clever in your system work. and trying to find out what's going on. So that's pretty much what's going on in here. It doesn't sound a lot, but to do the hydraulics up there, it's monumental. It's a massive task. So just to make some of the pipes, you have to source the materials. Just the unions alone and some of their adapters, they're crazy money. So just some pressure blanks and adapters, adding it all up, 10 of each type came into about £2,500. It's crazy money, but you can't do without it. So other things we got going on, if we go up the front here, so one thing that the VRT does a lot of, this is Joe, he's looking after some of the paperwork here. All the engineers do all the paperwork for each independent job. So if you're going to go and do a job on the aeroplane, you raise a job card. There's traceability then, so we know what's going on. So this is important. So, you know, every time you go and take your car out, do you know absolutely know what's wrong with it? Maybe not, but for this, everything's documented, everything's written down. There's maintenance manual references. You know where parts have come from. You know who's inspected what. You know who's signed off what. So this is industry standard. So there's a thing called A823 or a Part 145 company. So we try and run the VRT in line with that pretty much. So what we're trying to do here is replicate that. Even though we're not regulated, it's really, really good to have these systems in place. So if anything did go wrong, you've got traceability of what happened, why it happened, what parts were used, who did what. You know, it's not a witch hunt, but it's just a case of we're absolutely, as far as we can be, safe. And that's the main aim of the game here. You know, you're at an international airfield, you're operating with other aircraft operators here. We have to be on point with it, so safety is paramount. So with all the inspection panels off and all that, the engineers do get quite tired. So, you know, one thing that's going to keep everybody going is 17% more mince pies, and that'll keep us going through until 2026. Other bits we've got going on, if you look up the front here, you'll see all the engine doors are removed. You'll see the canopies off up the top there. We've got a new canopy up there called a tarpaulin. So the reason the canopy's off is because there's an inflatable seal that sits around the canopy. There's an air system on the aircraft. So when you charge up the pneumatics, it will basically use the crew door, so you can put the crew door up and down. And there's an inflatable seal around the bottom. The bottom one we're not worried about. The top one, it needs to inflate, because if the aeroplane goes out and it's absolutely honking it down the rain, we get wet, which isn't ideal. So you want to keep the aeroplane dry. So it's going to be quite difficult to get a shot of it, but basically under here, in this section under here, there's basically like a thing called, it's basically a top hat. So this seal has got a flat base with a hollow, and it goes up into tubing. So on the aircraft side of the canopy rail, there's actually a nipple that sits on the side of the canopy. So as the canopy goes down and it mates, there's a lever on the back of the mechanism up there. So as that triggers, it'll inflate the seal. So the seal sits in here, it sits around the canopy up to about here. So literally where the pilot's heads are, up to the back of back of the ejector seat. That seal will inflate, and it's for pressurization. So as the aeroplane pressurizes, it has to be sealed. Primarily for us, we're not worried about pressurization. We're not flying. However, it's nice to keep the aircraft nice and dry. So that's why we're doing that, which would be nice. So really and truthfully, that's a lot of the roundup from the engineering side of it. So the team have worked incredibly hard this year. We've held a lot of events this year. So hangar dances, proms, beer festivals, open days, VIP visits. It grows and grows and grows year on year, and we're really thankful for all your support. Wishing you a Merry Christmas, and we'll see you in 2026.